shiny metals. But how do we get them? In nature we hardly ever find pure metal, unless you're lucky enough to stumble across some golden nuggets. Yeehaw! Instead, metal occurs in rocks, and if there's enough of that metal in the rock, we'll call it an ore. But we have to mine it and then crush it so that we can refine it and get at the compound that contains the metal. What a pain. So now, how do we get from the compound to the pure metal? Well, some metals are more attractive, I meant reactive, than others. And importantly, more or less reactive than carbon. We're going to be thinking about carbon and how we can use it to refine some metals, but not others. Let's think about metals being cars, and potassium being very reactive would be a very fast and exciting car. Maybe something like a Porsche. Moving down to a more middle of the road Mondeo, well, nothing wrong with it. A very good car, but not as exciting as a Porsche, so that is going to be carbon. And then at the bottom, maybe some old banger, Robin Reliant, and that's going to be copper. So, we've got our metals in order, least reactive, bottom, most reactive at the top, and we're going to call that a reactivity series. Now, let's imagine that oxygen is a passenger in each car, and we're going to try and tempt the oxygen away. Fancy a ride, oxygen? Oh, yes, please, carbon. You're so much more reactive than copper. I'm going with you. So copper oxide plus carbon goes to carbon dioxide plus copper. Yeehaw! Copper metal. We've got it. Let's try that again with potassium. Fancy a ride, says carbon to the oxygen that's with potassium. No thanks, loser. I'm staying with potassium. He's so much more reactive than you are. Now, if a metal can replace another metal in an oxide, we call that a displacement reaction. A more reactive metal will displace a less reactive metal, and carbon can displace less reactive metals. So not all metals will hand over their oxygen. If a metal oxide will lose its oxygen, we say it has been reduced. Now, if a metal can't be reduced, then unfortunately we've got to use another method, electrolysis. This will